Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. We've just finished all the work for expressions with subscripts and user-defined functions and all the operators and all that stuff. And I wanted to move on, before we move on to more control structures, I wanted to do some cleanup. We've got inconsistent error handling in the interpreter, and I want to make sure we're, I want to switch to using try-catch rather than a mix of outputs and try-catch or something, whatever we're doing now. So we'll go ahead and jump there. Let's see. Yesterday I messed up the streaming or the recording or something. So I made a makeup episode in the afternoon, but I'll just do a quick summary today to say what we worked on. So we'll take a brief detour there. Okay. So basically it was two things. One was we got our string arrays working, and that was pretty minimal. I think we did some work in the parser. Basically, what we had to do was anywhere that used, well, any place that used an array, we made the type explicit and then made sure that it put number or string depending on what it had. So here in the parser, we added this type field, type for array name, that basically that method existed. It looks for the $sign, and $signs mean strings. Okay, so we basically push that from the dim statement or from the implicit use of the if you subscript on the left or right side of an expression, then it uses it there too. So we pass that type through, and then in the interpreter, which I don't have open, and I messed up something on the screen. But the interpreter, we switched to being an array of values, and so we could directly store, the fields, whether it was whatever type it was. So that was good. Just junk we'll clean out. Okay, that's left over from the other day, I guess. All right, but anyway, with the type in here coming in, we can ask the type for its default value, gives us a 0 or an empty string, and with that, we, everything works out. Okay, let's see. I don't have my chat open. All right, off kilter today for some reason. Okay, let's see. I just changed something, so let's make sure tests work. So the strings took about 45 minutes. They were not tricky. There wasn't much to that, so that was good. Mostly we could have passed that type along all the way through. It was pretty clear we'd need it, so I probably should have taken that much of a look ahead. The next thing I did was a little work in the in my environment. So I finally learned the keystroke that's go back to the previous place you were. All right. Which is Control Command arrow in Xcode, or go forward, I assume. Yeah. I don't know what I was trying before, but I didn't have the right commands. And then I also added a refactoring menu. So rename is Control Command R, Control Command M for extract a method, Control Command V for variable. So if I do that here, okay, we can get the expression and so on. All right. So that didn't take too long, a little annoying. And then finally, some work in the lexer. And let's see if I can get that shown. All right. So the basic structure of our lexer, well, it's more or less a state machine. It looked at the first character, and if it's 0 through 9, it goes into digit processing. So finds the string of digits followed by an optional period, followed by more digits, and so on. Or strings in quotes, we go through and pull the characters. But we used to have cases for less than, greater than, new line, and all the one character operators. And instead of doing them in the state machine style, I switched them And now we moved, we have this notion of a prefix token, which is a token that's kind of a constant token that matches the beginning of the rest of the input. Okay, so reserved words and go to whatever, they're all reserved words. They don't change. They're not like a variable or a number where there could be lots of possibilities. It's just there's that reserved word. Okay, so it just looks for that first, and then it can do that same mechanism. If it sees a plus sign, it knows the only thing it can be is an addition. So it pulls those. So instead of, I don't know, 8 or 10 cases here, we're down to 3 real cases. And the prefix tokens thing, these were 1 character matches. Now they're multi-character matches. And then a little bit of trickiness that we really do have to arrange them longer to shorter, because if we had put less than first, it would match less than, even though maybe it should match less than or equal or not equal. So there's a little bit of sequential dependency across them. The keywords, there aren't any that are prefixes of others. So if there were a go keyword, we would need to put it after go to and go sub. All right. And that also, well, my editing skills were pretty bad here. I tried to do it with multi-line editing and completely messed it up. So I ended up spending more time. I probably should have just reverted and hand edited it. But anyway, it's there now. All right. So that passed. Let's commit that. Delete comments. Okay. Hope I have internet. Good. All right. And now the interpreter is where we want to focus today. So let's see. So here's one. Default, return improper L value. All right. So the way we handle output now, we pass along an output string and basically append to it. So in the sort of normal case of an assignment, this is assignment. So if you said x equals some function, some expression, it evaluates that and assigns it, and it has no output. It's not a print statement or anything. It just returns the output you have. So we're passing that string, which is potentially all our output. Okay. Now, in some cases, we detect an error, and sometimes what we do is we return an error message replacing the output string. Other times we append the error to the output string. And I don't know, is there another way we do things? Let's see, expressions. Yeah, evaluate. Okay. What can you have? Value.number, store subname, string. Well, those don't really mess up. Maybe there's something in operators. No. Yeah, let's see our map of functions up here. Okay, can anything go wrong? Well, not much. We already know the types are correct, so that's probably okay. Gosh, I feel like there was something. Maybe in these function things. I don't know. They're kind of minimal. User-defined function. There's one. Okay. This one is returning a value. So the value is, we've said it's a string, even though maybe this user-defined function, actually all user-defined functions are supposed to return numbers, which is a value type. But this one says, oh, if I don't know the number, I'm just going to return a string. Well, I don't like that. Okay. So, and I don't know if we've tested this either. That's another thing that I'm not so convinced we've done well. Lots of times when you try and do this stuff, like I want to fetch the parameters and the definitions, I've got to do some sort of if let or guard case or whatever like that lets me do it, and then I can use them on my happy path. But I had to leave a sad path in there, and I know I'm not super good about testing that. So let's just see if if this string appears, actually we'll start at the front and go in our tests. Search without filters. I don't know what filter I had on, but okay, find text containing that. Okay, yeah, so nobody is even looking for this. All right. And I think that's a problem. I think we should. All right. So what I expect to happen is most of these, any of these that can throw an error, like assign, I would like them to throw exceptions rather than return values. Now, how fancy our exceptions have to be? We've got a couple places that throw exceptions too. So I'm up to 4 mechanisms, right? You can see why I'm not so happy. All right. Yeah, so we added a couple. I don't know if every individual problem is better off with its own error, because you really can't do much about it. Okay. Right. I mean, all you're going to do is report it, and maybe one single unified one. Really, I would like to know the line number and the error message would probably be enough. Yeah, I think that's what I want. So, let's see where to start. Oh, and one more thing. The line number, there's some complexity around that because let's find our main loop. Okay, here's our run loop. That's sort of the heart of the interface. You can run or you can step. Okay, so this, we look up the current line number. Line number is the current line number. We default it to the following line number, but the goto can override that. I'd like to maintain the line number. Yeah, what I'd like to do is have a next line number field, and if the line number is not, sorry, if the next line number is not set, meaning there was no go to or go sub or something like that, I would like to default it to this. Okay, so that should be a neutral change. Okay, so I think, okay, let's try that. Here's line number. Let's do next line number. And this is optional because you may not have set it. Okay, so program first line number. So we start with the line number being set. That's good. All right. I think we want to say, how do we want to do this? Well, okay, maybe step 1 is this. I can say next line number equals that, and then my goto, I'm going to say next line number equals that. Okay, so now I've set next line number, and I got to use it. Okay, so I guess before here, yeah, I think I want to set it here too. Yeah, let's see. So when I come into my loop, I'm just starting out. I should either have, well, I might have a next line number. Okay. So if I have a next line number, I want to use it. line number equals next line number not nil. Well, sorry. Yeah, if it's not nil, I want to use next line number. Otherwise, I want to use this. Is that? Oh, if it's not nil, I know I can do that. Okay. What's complete now? Okay, program line after. And let's make sure line is nint. Line is a, oh, sorry, next line number. Oh, line number is required. Okay, so I think what I want to do here is next line number equals program first line number, and let's just start line number equals 0. So we're just saying there's no current line number, and we got the new one. If we come in here and we don't have a next line, well, if we do have a next line number, let's use it. If we don't, then we need to get it, and this function returns an int. Okay, so I'll just do a build. Maybe it's not caught up. Okay, yeah. All right, and then now I don't think I need this here. So I'm kind of moving this up. I'm flipping the order of things a little bit. So it's not, again, it's another one of these not standard refactorings. I have to kind of argue my way through it. But I'm saying line number starts out completely wrong. 0 is not going to be a valid line number. But next line number will be the program's first line number. If that exists, use it. Otherwise, we're going to find the line after the current line number. Okay. And then, yeah, so now in the body here, line number is the current line number. Before, line number was the next line number or the go-to line number. So the change that we're getting is this was always called program line after, but in a go-to we throw it away. Now we only call it if we need it. Okay, so enough arguing. Let's make sure the test pass. And I did change that go-to, I hope. Yes. Okay. That pause the first time, just there we go. Uh-oh. Are we? Failed. Okay. I've messed something up. All right, let's try again. By try again, I mean throw away interpreter and do it over. Whoops, not that far away. Discard changes. Okay, make sure test pass. Okay, let's do it in a smaller step. So let's add next line number. Number of int question mark. Okay. Let's try. I want to set here next line number, and here next line number. I'm going to not move the stuff around and see if I can make this work. Okay, so at this point, think I still want to do this. Line number equals 0. Next line number equals that. And I'm going to set line number equals next line number. Oops. Okay. And that should build failed. Okay. Because in this code, it's always set. This returns an int. Go-to returns an int. That should be good. Oh, 30, 50. Okay, what's going on here? Wow. Interpreter test 225. I've set up some sort of infinite loop, apparently. Interpreter tests. We can stop at 225. 10 go to 10. Well, okay. That test should fail because we're just doing a step. Yeah, so this is legitimately different. The reason we did this test this way is because 10 go to 10 creates an infinite loop, so we're just going to run one step of it. Really, it should be next line number, but something else is failing as well. So many passed, and then we got stuck. Okay, what's this one? Interpreter test line 16. Check program results. Okay, well that doesn't help so much. 30. Okay, if 1 then 50, that should go to line 50. Expecting 50, and it printed 3050, which means it didn't take its if. Oh, yeah, that's another go-to. Okay. Then, all right, line number. Okay, this should be next line number. Matter of fact, let's look for line number. Line number equals 0. Next line number, next line number. Good. Okay. Next line number. Okay. I think that's better. Let's go to that one test, the 1010 one. This one should pass. This 1010, this really should be next line number. Since now line number is only set in the loop, not by the end of the loop. Okay. And what was the other failure? 3050, that's a good failure. Okay. A helpful failure. Okay. Oh, probably the same thing. Step loop code. Single line. Yeah, this should be next line number again. Okay. Now there, yeah, that's correct. That if you say 10 go to 20 and that's the only line you have, it will attempt to go to line 20. I do think we would need to make sure the program reports that error eventually, but that's a different test. All right, so introduce new line number to support if and go to. Okay. Now the reason I want this. Okay, so I'm getting a different kind of invariant, I guess is the way to say it. In the way I was before, with this brief moment you had line number was the current line number, and then we changed it. And so through the whole rest of the code, if you ever referenced line number, you were talking about the line after the line you were on. So for our messages, I want to make sure that we're talking about the line you're on. So that's really the justification for this. I should have said that more soon. Okay, now what is going on that okay. Well, I realized one thing. I never reset next line number back to nil, so that's a problem. Okay, maybe that's what I needed to do. Okay, so let's try that move. So if next line number is not nil, then next line number. Otherwise, I want to get this. Okay. And I want to set next line number equals nil. And I believe I can comment that out. Okay, so let's see if this is better. All right, so line number is the next line number if it exists, meaning, well, the initial state sets one, a go to, an if statement sets one. If it doesn't exist, we look up whatever's after the current line number. Okay, and that will always exist. We stick an extra, we stick a line that says and an end statement by default. So there will always be a line after the current line. And then we clear the next line number because nobody's done a go to at this point. All right, let's see if this works. All right. So move calculation of current. Well, how do I say that? I think it's really only look up next line if there isn't one available from if or go to. Okay, so I'm happier. All right, now what do I want to do? Well, error messages.count. All right, so here's our first set of problems. I don't know if I want to, which ones to work on. This may not. I don't think that makes sense. It's kind of a can't happen. How do we handle that? Okay, I guess we're exhaustive. Again, like the parse, why does it have an error here if the error messages is what you use to look at it? So I think we just are inconsistent, and putting all the messages in, I guess, is okay. Yeah, I didn't really want to focus there. Okay, what I really wanted to see was where are places now. Like here's one, a dim. If they've already dimensioned it, we throw an error. Okay, let's make this. Let's take that different approach that I was suggesting. So instead of can't redeclare array, let's just say case error with a line number, which is an integer, and a message, which is a string. Okay. And here I want to throw error line number can't, what do we call it? Redeclare array. How about plus name? Okay, so let's be a little helpful. All right, I don't know if we test that. I probably should have changed it and then tested it. Maybe we'll do that. One failure, yay, okay. Yeah, okay. So we dimensioned, let's see. This probably belongs in the other order. Oh no, you have to get the program. Okay. We created a program 10dim a sub 2 and passed it into the interpreter, but then we modified the interpreter state so that we already put in a global variable a and made it just a variable. Okay, a simple variable with a number in it. All right, and now we run it, and our output is can't redeclare array. Okay, so I don't like that being the output. Yeah, how do I want to handle that? Is this where I do the try catch maybe? Should run throw an exception? Okay, and the problem is right now output is everything coming from that interpreter.run, and I just don't like that. Okay, error 10 can't redeclare array A. That's definitely a better error. Okay. What do we want? Okay, well this throws, right? So this method must throw what? Throw interpreter error. How does this method, does it catch him? Oh, it does. Okay. So what if step throws? Let's see what we can do. All right, so now I'm, I guess I should fix my message first. Let's do that. This is now, well, it's really that, isn't it? Okay, this is what we have. I'm not sure about that. I think that may be an artifact. I think you can put single quotes and double quotes. Maybe I'm wrong. Really? Error 10 can't read. Okay. All right, what's going on? Error 10 can't redeclare array is not equal to. I guess I got to do this. It'll get washed out eventually, but it's weird. Okay. Can't redeclare array a quote. Oh, paren. Okay. Yeah, that's not so great either. But we'll, okay. We're there anyway. Whoops, interpreter. Okay, so if I say, when you get an error, we throw an exception. Okay. Call can throw. Oh. Okay. Okay. What's the complaint? Yes. Okay, so this the error is not caught. Okay. And what do we want to do? Okay, I think what we'll do is we'll do this in a catch. Let's make output equal error. Okay. And let's stop the loop. Done equals true. Okay. So when you get an error, if you get an error, we set some output and stop the loop. This will break some tests, but I think it's what we want to do to step forward. The test that'll break, okay. Oh, all of the ones calling step need to deal with this. Okay. Let's just do throws. Oh. I had more steps than I realized. I guess that, yeah. Before we had the programs running all the way, I think we used a lot of these because they can take the parse instead of the line, and we could control the parsing without, we could test independently the parser, which isn't horrible, but it's making a lot of change to allow this. John Reed has his test templates that put that throws in there for you every time. That'd be handy, wouldn't it? Guess I need some of these. And some of these tests will fail. Call can throw, but it's not marked with try. Build succeeded, and yet we still have an error. All right. Let's run these. Well, I'm going to start with interpreter tests. I think we'll find enough issues. It won't be everywhere, but we'll probably have at least a few. Okay. Well, I guess it is okay. The place I was worried about is, I guess the only one that you should get an error on is that can't redeclare, and we don't actually escape. So all we did was change the interface and not the behavior. Okay, so let's do that. So make step able to throw. And I think in the interpreter step, well, we have this code, but the case we looked at, this doesn't happen because we catch it internally. If it happens, we do the dim. Well, we throw an exception if the error happens and then return that error. Otherwise, we do the dim and return the output unchanged. Dim shouldn't. It's like an assignment. It doesn't have a printing side effect. Okay, and which is another thing that makes me know that we shouldn't mess with output if we don't need to. But so I want to move this up, but notice it was output plus error before. I think for consistency, let's just make the output be the error, and let it go from there. Now, step already throws, so everybody's prepared to catch this stuff. All right, so I want to move the catching outside. And it's only this one case for now. All right, that can go like that. Okay, so if the name already exists and we call dim, we should get this error. And I'm trying, I'm giving you the line number and the name of the array. So let's hope. Okay. And I think the test we just touched might have put some output in. I don't know. Maybe it didn't. Maybe the only output was the error. Okay, good. All right, so make dim throw error to top. All right. Oh, it was def, wasn't it? Oh, no, it was dim. Okay. No errors in these. Okay, I guess dim's doing a little work in this thing. A lot of these call methods. Okay. Operators, I don't think we have an issue. Now, evaluate, I'm going to defer that one. Yeah, let's skip evaluation. Call format. Oh, this should be value. I don't think anybody looks at that. It's theoretically it's a can't happen, but that's okay. Print. You can see because there's a lot of places that call evaluate, so handling it's gonna make some challenges. Okay, do dim doesn't have any mistakes in here. Index 4. Okay. All right. So now I guess everything is evaluate because that's mostly what we do. We have the if statement and a go-to statement and a bunch of expression stuff. Okay. Evaluate. I'm going to make that thing capable of throwing. And that's going to affect a lot of call sites. I don't have... do I? Is there an incremental way to do that? Let's see. Well, the incremental way would be maybe... Okay, let's be incremental. All right. Eventually, I'm going to have to do that. But for now, I'm going to say anybody who... I'm going to say this. Let's put this all in a do catch. Okay, to the end of the switch. Okay, so here, whoops, here is the catch, and right now nothing should happen. Yes, no errors are thrown in the do block. Okay, so my incremental way is rather than make everybody who calls evaluate go crazy, I'm going to do these little helper functions one at a time as much as I can. Okay, and actually many of these, okay, this one's legit. This one is pretty well legit. If you evaluate a number, you return a value that's a number. Yep. A variable, you look it up and you get a default value. There's theoretically nothing's going wrong in that. Same thing for string. Okay. Call predefined functions. Is there a possibility of a mistake? Well, of course. So let's see what we have to do here. All right. And I'm just, these multi-argument ones where it stretches out so long, I've just been splitting these lines. Okay. Function equals store some name. Theoretically, that can't go wrong. If it does, it's an internal compiler error. Evaluate those. Okay, that can eventually be problematic. Let's see function.apply. Oh yeah. Okay. Well, this is a can't happen. In principle, the only way to call this is to be from a function. So it's all right. Who calls this? Maybe this is a good one to just make a throw and not worry about it. Interpreter and value. Oh, this is value. Okay. Interpreter. All right. So I don't know. These can't happen ones. If you apply. Well, okay. Value.string. Maybe we have an error case for value undefined. I think maybe this is one of those. I mean, I think this is a can't happen. And we'll return undefined. Undefined. Is that better? Type string. Function as string. Wait a minute. Function.apply. Function is a value because store returns values. So function.apply, is he always a string? I don't see how he is. Okay, so function applied to arguments. It should be a value. Maybe I just did that wrong. In principle, this is a can't happen kind of thing. Oh, I was editing as string rather than function. Okay. That makes me wonder if undefined is the right thing to do. In a can't happen case, it may not, probably doesn't matter. Okay, let's test. Right. Okay. And then interpreter. This, I guess that's okay. Let's go back. I guess I'm going back a bunch. Okay, evaluate. Predefined functions don't seem to have errors. User-defined functions, I'm pretty sure they have errors. Okay. Function not found. Yeah, that really is. Is that correct? No, I don't. I don't know that. I don't think that's a can't happen. I think that's um, if you called FNA but you never defined FNA, then looking up the name. Hmm. I guess if the name, yeah, I guess what can't happen. All right. So the function FNA, if if it gets looked up in the store and it's there, then it's got to be a user function because FNA is always a user function name. However, if the name is not in the store, can that happen? And I don't. Yeah, I think that can. So let's go back here. I think this is a can't happen, but this is a can happen. All right. The other thing is I'm going to move this down. Okay. All right. So I don't feel bad. All right. Let's do this. Let's write a test. Okay. So find our user defined functions. Okay. I don't think we have a case for this. All right. So call on undefined function fails. Well, it's actually pretty simple, right? It's just 10 print fnx of 0. I suppose I should put that on a line. And the results we expect, I think we expect well, we expect our error message. Something like attempted call on undefined function. And this is in line 10. Okay, and if I get some version of that, I'm content. Oh, but he won't, will he? Okay, something should complain. It may just blow up the way it is now because it just hard codes the, hard codes the nil. I mean the store name bang. Okay, so we can certainly move it forward. If the store subname is nil, then we need to throw an error. Interpreter error dot error with a line number and a message. And our message was in our test. I forget how I split my window. No. Okay, well, my mirror error is something like this. Undefined function, and let's put the name. Okay. Now, yeah, that means this can throw. That's a little goofy. Okay, and somebody should be complaining. Yeah, where's the call here? We should do try. All right, and now if we catch the error, let's do output equal error. Okay. All right, and our test, we'll start with this one. Yeah, okay, I missed another one, huh? Cannot find output in scope. Oh, I probably just had to return. Oh. This is why I want to do it the small way. Okay. Value. I feel like we're going to have to make an error output for now. Well, what we've been doing is this. Let's do something like that. I don't know what will happen. I'm going to take a partial solution, though, just to get things done a bit at a time. So let's try again. But I don't know if anybody else will care. Nobody else is expecting values. Yeah. Okay. Error 10 is not equal to 10. Okay, that's pretty good. Error 10. Function f and x. Error 10. Undefined function. Oh. Have I got extra parents? Wait a minute. Error 10 attempted as I guess I do. How am I getting an extra paren there? I'm not seeing it. Okay, attempted call on f and x parent quote. Okay, I mean, if I take this out, it's going to complain, right? Error 10, attempt to call an undefined function f and x, quote, that. Oh, new line. Why do I have a new line? Oh, because it prints it. Okay. So I need a new line. F and X. I need a quote here. Quote. New line. I think I'm good. So, make attempt or get failure if attempting to call undefined user function. Alrighty, and then that was you call user defined. Whoops. Definition. Okay. Now this one, this is kind of a can't happen. And maybe that's worth differentiating. Let's find our parser errors, interpreter errors. Okay, let's do a can't happen as well. And I don't have to test it because I don't think I can make it happen, but name again. This is interpreter error dot can't happen. Okay, and I think all tests. Oops. Return type value. Oh, he's a throw. And I think can't happen internal error is already its own sufficient explanation. All right, and the rest, now we're to evaluate. Okay. Let's get back up to the case. So we got down this far. Let's pick up with array value, but we've gone a while, so let's take a 3-minute break. I'm gonna grab some water and be right back, and we'll go ahead and try and finish the rest of these, which maybe I think up until the point of evaluate is probably okay. So we may need to make evaluate throws to make some of these get some errors. But anyway, we'll come back in 3 minutes and start that. Hello, welcome back. All right. So array access might have some possible errors. Yeah, we know it does. All right. Okay, so try to subscript a non-array. That's plausible. Let's make this throws and see who complains. Yes. Okay. Run our tests. Okay. Does dodim cause problems? No, I guess not. Okay, in this case, we're going to throw this is an error. Error. Line number. And then I think try to subscript non-array plus name. Okay, I should undo that. Okay, let's run tests. And let's find this. No, search without filters. Okay, so that tells me nobody tested this either. Okay, I gotta change something in how I'm doing these. I had this notion of obligations, and the idea is you do certain things, and it's one thing to be on the main path of it, but you're spinning off obligations. And I think what I've done is I've not kept that notion very well. I have obligations to test. If I'm going to return this string tried non-subscript, I need to at least have a test for it as well. And because the structure, this matching the guard cases and the iflets, they tend to spin off these things. You can't get to the name of the dimensions without this kind of test, and yet it could create, it could detect a problem. All right, and this is good. Okay, so let's get a case in here. So this is you. I guess if you say a equals 7, access a sub 1, print a sub 1, would that do it? Because we want it to, if it exists. Okay, so the nil is not there. So yeah, that's like a really good case to test. Just saying. Array dim knows its size. Okay, let's get down. Array access. Okay, yeah. This. Okay, so can't access non-array as with subscript. Okay, so we say a equals 7. Next line, print a sub 0. We expect some message. Okay, and I guess I could do this. I know it's going to be error. Well, no, I don't. Let's just get started. All right, try to subscript non-array A. Okay, so we are closer. Interpreter, fetch array value. All right, so now I want to do my throw. Interpreter error dot error. Okay. is 20, yeah. Error 20. Non-array A. Quote, parend, new line. A, quote, parend, new line. All right, let's see how that does. I feel so much better just getting a line number in there is progress. This thing of like, your program has an error is not so helpful. We found that out the other day trying to write a fairly long test in BASIC. Okay. Now this one, is index 4 complaining? Index 4 array access out of bounds. Okay, so let's see if anybody's looking for that. Yes. Okay, so let's change this. Well, we can change the expectations. Yeah, I mean, I think we're going to get just one line out of this, but it's going to be error 20 array. Well, tell you what, let's just do this multi-line thing. Error 20 array access out of bounds. Bounds, new line. Error 25. Okay. That will fail. Quote, quote, new line, quote. All right, run all tests. Okay, we get array access out of bounds errors. I don't know why these keep reformatting on me. All right, same thing there. Okay, so let's make this instead of that it should be error line number and array access out of bounds. Okay, and run tests. That's what I want. Okay. Error 20, array access out of bounds. Error 20 is not equal to error 20, array access out of bounds. Error 25, array access out of bounds. I think maybe that might be the issue. Okay. This one, array access out of bounds, is not equal to, yeah. Oh. Array access out of bounds, that. It's saying no new line here. We're not printing that error maybe? I don't know. I guess, okay. How do I run all 170 or am I just getting the 2? Good, okay. So we made access out of bounds, use the error. All right, back to the interpreter. All right, we're going to go back. Okay, pass the tests. Index 4. There, okay. Yeah, so that's where that new line stuff's coming. Now we're going to let this error bubble out. So kind of replicating this approach in the small. If index 4 throws an exception, we're going to catch that in the main loop now. This. Okay, and so they may change the new lines or something, but I think we'll see. Okay. Fetch. Okay, we'll make fetch array access throw errors. Good. And that was it, right? Okay. Now fetch array value. Oops. Now this is the one I don't know how to do in an easy way. When I say throws here, even though we don't throw anything yet, there's going to be a gazillion places that have this problem. Okay, now we're in a situation where I don't think it's going to hurt anything to say throw, because we do catch the exceptions in this method, but there are other methods out there that call evaluate. All right. Like call predefined function. Okay, so this is a try, and if it does blow up, it it needs to deal with that. All right, why are you? Call can throw. He's try. Okay. Call can throw. Do I need this then? Okay. Yes, I do. Now this one already throws, so that's okay. Format. We didn't see that one. I was going to say, I'm surprised it doesn't complain about throws, but let's do that. We're going to have some places that called format, the print command, and so on. Okay. Oh, do print. Yeah. Okay. Try values. Throws. This is a try. Do assign. Try, and it throws. Okay, we got some work to do here, but index 4 we already deal with. Probably have to have a try up here too, right? Okay, we still got a few places. Errors thrown are not handled. Do if then. Okay. And there are going to be tests that have this problem too. Yeah. Okay. So let's do step throws. Okay. So this is okay. Try do if then and do assign. Okay. I believe tests are going to have some failures. Pretty sure we call. No? Okay. Yeah, there we go. Interpreter.evaluate. This is a try. Throws. That's the only one, huh? Okay. All right, good. Make evaluate throw. That had less impact than I feared. Okay. Let's go back down to our evaluate. Oops. Evaluate. Okay. Now, if it catches an exception, it just wraps it in a string. All right, we had other places that now do throws. Define interpreter error. Can't happen. Okay. Okay. One thing was format. Oh, do print called it mapped format. Okay. So do print may throw. Yeah. Okay. This may throw if evaluate. Okay, if evaluating the expression fails, that can throw. Okay, that's fine. This one's a little more complicated. Okay, yeah, here we go. If I think we have the same. This is okay, but if global's name equals no created. Okay. Oh, this is the same kind of thing we had before. We had fetch up here. Fetch array value. Right. We had this line. Assign. Well, let's just paste this in and look. Okay, attempted to subtract subscript non-array. Yeah, that's what that would be. Let's try this again. Did anybody reference this? I think we have another missing test case. No. Okay, good. So we want this test case to fail. I mean, it's going to become error in line 20, error line 20. It's something like that. Okay. I guess it has a quote, paren, quote, array. Yeah, something like that. All right, this will fail because it's got the old message. Error 20 activities and arrays array. I think that's close. All right. All right. And the message will be a little wrong, but we'll fix that. Try to subscript non-array A. Try to subscript non-array A is not equal to error 20. Oh, we have no new line. All right, and run them all. And I must have deleted a couple tests along the way. Let's just clean that. All right. Use throw for subscripted assignment errors. Okay. Okay, so now this do catch. Okay, default proper L value. I don't know if that's a can't happen again. All right, so do assign. Should only generate one of those two cases. So let's find do assign. Assign. Okay, it only finds a variable. Requires equals. Wait a minute. Equals. I'm puzzled. Okay, so I see a sign here. In our interpreter, we allowed for array access. How is that not showing up there? Variable. Oh, okay. Variable's a little more sophisticated. All right. But yeah, so the only way you can either return variable or return array access. We don't really allow anything else. So it's more of an internal error can't happen. Okay, so down here, all right, and then this, we're doing an output plus error. This should really just be our throw. So basically index 4 and evaluate, either one could have an issue. If they do, then we want that to come out from the exception that they throw, and we're not going to catch it. We're going to let our caller deal with it. And this is do assign. Jump to definition. Oops. Find use. Return try do assign. Okay, so that's in step. And it just throws. All right, and again, there may be an off by a new line kind of thing or something here, but I think we're closing in. Okay. Let's see, let's push this. So we did the can't happen. Okay, let errors flow out of do assign. Okay. And then I think let's look for error. Okay. Can't read clear array. This one's suspicious. All right. So evaluate. Yeah, nobody's errors really come out of evaluate now. But it does throw, and every caller is prepared to deal with the throw. So let's take this out. Indent these. And this catch doesn't happen. So now they're no longer wrapped in a value. They're just flowing out as pure errors being caught. Okay. And let's see if everybody's happy with that. Yeah. Okay. I feel like these may not be real issues. I think it's a new line issue. Yeah. Okay. If it's just a new line, I think we're okay. Because that was another inconsistency we had. We've eliminated that. This one may be only happening once. Yep. Let me undo this. Let's do this in 2 steps. Okay, if you do the first one, and I don't think I need the triple quotes when it can fit on a line. And then you'll get that. That might even be better. All right, and this is because in the old way, we would just append any errors that came out. The new way, we throw the error and we stop the loop. So that's an improvement. All right, let's run all tests again. Okay, and this, I think we want to say, basically we're saying evaluate, let evaluate bubble its errors to its collar. Out to its collar. Okay. Oh, I'm feeling so much better about this thing. All right, let's go top to bottom and just see how we're looking. Okay. That's okay. That's fine. Okay. Missing. All right. Is anybody referencing this? All right, these functions pretty much just do their job. All right. And notice we were able to put our correct error line number in all our errors, so that was a good thing. All right. Do output equals try step. I think this could be better. Let's see. What are we saying up here? Improve error handling in interpreter. Okay, I think every step we made was an improvement in my book, so we'll take it. All right, and then back through our skim. This one, let's handle parser errors better in interpreter. Okay, so that's more. We'll make a to-do out of this one, but it would be nice. I mean, I guess I'd be happy if parser could even throw, and I wouldn't be too upset by it. But yeah, this is more work than I want here. I could push this over to the parser if nothing else. Okay, let's keep looking. Error. This, I think, is kind of a can't happen here, because if there were any mistakes in the parser, we wouldn't be down here trying it. Okay, so I believe this is a can't happen. We break out of the loop. Okay. And that makes me suspicious of the parser as well. This one always bugged me a little. It's a little off our beat here, but the line number. Yeah, I don't know. We call it recursively one level deep, but within there you never have a second line number, so there's no problem. If okay, these all have tries. User function, that's a define, okay. And the parser did all the work to validate it. You know, it's actually, you're not actually allowed to redefine a function. Okay, so let's catch that. Def dim. This output still. Okay. The operators, not much there. Evaluate. Missing. This is this case. One of the string functions allows an optional third argument. So I think if you actually try and get that value, we're saying the value is undefined if the argument is missing. I guess that's okay. All right. These look all right. We did those. Okay, here's the operands. If they have an error, they just throw. Okay. Errors throwing. All right. Format. Try values, map format. Okay. Right. Okay. Index 4, we've got to throw here. This, well, I could flip this. How about we say zip indexes dimensions dot drop first. And then reduce. Run tests. All right. So that was okay. We're at the bottom. So basically, we started off with 4 mechanisms for error handling. We're down to, I would call it 1.5, I guess. Everywhere in the bulk of the code that deals with an error does a throw statement, and everybody who calls one of those things is prepared to catch what they throw. So that part's consistent throughout the body of the interpreter. The place that's still a little inconsistent, or, well, I don't know that it's inconsistent exactly, but this, we catch the exception here. We could say, if you call run, you better be prepared to get an exception. That sounds plausible to me, actually. All right, let's do that. So we'll do the same thing as before. We're going to change the callers to say, you should be prepared to accept an exception. But we're not actually throwing one. We just return this and break out of the loop. I think that's a good thing. All right. So certainly a bunch of tests are going to complain, and probably REPL. So let's run tests. Yep. Okay. Here's REPL. Do run. Okay, and what do we want to do here? Well, I think we should be prepared for this error. So let's do a do catch. And that catch is pretty much what we got here. Yeah, done will not be an issue. Okay. And REPL. Well, let's just append the error. Okay. This makes me wonder. I mean, at some point, we need to shift from let's see. So the errors that we get, right? We had error and int. This can't happen. Almost. See, I just want to handle the one thing. Let's see if we can do that. Okay, so I want to put line number colon message, and then otherwise that. Okay. So if you get an error and it's an interpreter error, then we're going to format it somewhat nicely, and maybe we want a question mark here. Okay. And otherwise we just append the error. We've got to be complete here, but I think that's okay. Now these, okay, check program results. I guess we want to fail if this. Let's go to the next one. I'm okay to let that escape. All right. Now I've got to deal with program results. All right. So if you do this, okay, let's just put it into do catch. Do. Okay. And my justification is everybody who's calling print check program results, I believe they should not be expecting an error. So if they get one, we're just going to force a fail. and I'm not going to bother making the throws on the check program results. I'll just make it an assertion failure. All right, and run all tests. Expecting them all to pass. All right. And okay. Okay, so the changes we did, I think of them as kind of a medium level. I mean, this is a relatively small program, so it's not that big. But if you add a throw clause, like every previous caller is at risk. Okay, and so what you saw was I split the throw from the throw clause, the throws from the actual throwing of the exception. So we made sure that the function caught its own exceptions and then did something with them that didn't throw. Then we added the throws clause so that all callers needed to be prepared to deal with it. Then we adjusted the callers because you have to do that syntactically, and they don't have to do anything fancy. Like tests can just do throws and stuff like that. They all have to try on them. But then we changed the exceptions to actually throw from the method. It's you're still stuck with that step in the middle where when you change the method to say I throw, then all of a sudden every caller is at risk. The only alternative I have is you could make a version that throws and kind of migrate callers one at a time to that would give you the step-by-step migration. And actually you could make your non-throwing version could call the throwing version and wrap that exception handling in it. That, I guess that would be the way to manage that. None of this, I mean, the most was about 10 maybe calls at a time to adjust. I guess the evaluate had a bunch, maybe 20. In a big program, if it was 500, I couldn't just say, oh, I'll just edit those and then fix them and we'll be good. I'd have to take one of these other approaches. And yeah, maybe I'll write that one up. It's enough of a pain. And part of it's a Swift thing, like explicitly saying try. In Java you can, Java kind of messes it up too. Java messes it up because the declarations all have to say, the exceptions. And Swift, I think it's a mess up to say I don't know. It feels like a pain to me to go around adding try. But I guess I got to do catch if I don't. So I don't know. I don't know. It gives you some some help to say, oh, this is the line that could throw. Line 15 is okay, line 17 is okay, but 16 is a problem. There's something to that. I don't know if it's enough to outweigh it. Yeah, I just don't know. But on the other hand, I think, do we have any changes? No. Okay. That was, I'm glad we did it. Okay. Oops. Error if you redefine a user-defined function. Let's check that error and then address it. Interpreter. Call. Where's the step? Oh, there's define. Yeah. Okay, so this thing. No, I thought I had a test for that. Interpreter test. Def. I don't. Okay. Let's. Well, it's really a check program results thing. Let's do it that way. Test def can't redefine function. Well, again, there's no throws here because check program results deals with it. Let's see. So this is check program results. And the string is, we're going to say 10 def fna of x equals x. And then 20 def fna of x y equals 42. And we're expecting some sort of error. I think we're expecting something like this. 10 can't redefine function. Okay. I can tell I'd be. Yeah, I kind of wish I'd done this a lot sooner. You'd think by the time you got to 4 mechanisms, you'd say, you know, something's not quite right. Okay, so we got no output, but we should have had a message. And it's really the same kind of thing. If global sub function name is not nil, then we can't redeclare function name. And let's get the text the same. Can't redefine function. Okay, run them all. Oh, yeah. Line 20 is the error point. Oh. What? Oh, yeah. The error. Yeah. Okay. The internal form is this. Is that right? No, wait a minute. Check program results. Okay, let's go over there. Output expecting. Run. Did we not get rid of the exception stuff? We did not. Ah, okay. Let's do that. This is really an error case. I think our tests. I'm going to break a bunch of tests. Okay. Let's call this check expected error. Differentiate this case, okay? And let's do that up here. No, we want the string. Okay. This time we're expecting the error, so let's do it the other way around. XCT fail. Should have thrown error. And this we will say interpreter error dot error let line number let message and then this do I care about the line number? I'm going to say no. Something's going to. Okay, I guess I got to look at the def can't redefine function. Okay. Can't redefine function is not equal to 20. Okay. Can't redefine function A is the message. Yeah. Let's run this one. Okay, so this is a check expected error. Function 10, we're expecting attempted call on undefined function f and x. I don't think I can call my check program thing here. Okay, so this. dot error. Line number will skip. No. Okay, this goes away. Okay, so I'm catching it by hand here. That message. Let's run it. Okay. Kind of blending two things, aren't I? Okay, well, check expected error. Program string expecting. All right. And I want to add one check for the line number case. Or do I care? Maybe I don't. I guess I could add one. I don't need a multi-line. Did I get missed one? Right. Check that def doesn't redefine user function. Okay. And then the last thing, I guess we'll just find our first error. and check the line number on it. That's a parser that's separate. Okay, I can make up one. Let's see. Well, I guess we're gonna have to do this kind of thing. All right, test error messages. Oh, it's a parse error. I gotta do a runtime error. Well, we can do a. Let's find a sub -1. Okay. Function test error message includes line number. Okay. I'll paste all this stuff. Let program equal 20 print a sub -2. Okay, try and run it. Should have thrown an error. Interpreter error. Let's catch the line number. And now we'll ignore the message. And check that line number. Equals 20. And I'll let this fall off the bottom if something else goes wrong. And this can say throws. We'll run this one. This should pass. Okay. Let's see. Make sure errors include a line number. All right, very good. So we did this one. The big thing was the error handling overall. We got down to a single method that says we're using throws. We're not throwing extra output in or any of that stuff. So we did that. We refined a few messages. We refined the way we check for errors. But I'm really happy to make this better, okay, because the debugging session we had the other day with that 20-line basic program, it definitely revealed that our error messages were not super helpful. Now, I think there's still some issue, like how do we handle output versus errors and all that stuff we'll address. I'm not sure next time we may jump forward to some of this, but we may spend some more time on this. We'll see. Anyway, next time is tomorrow, Thursday at 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. UTC, or whatever your local time zone is. I'll let you adjust it. And thanks for joining me today. Hope I catch you in the future. Take care. Bye-bye.